Okay, so I'll give you a second, or pause it, and copy this down, and then I'll explain what it means. Again, these up top on the numerator is just representing a polynomial. They use the a sub n here as the coefficient to the nth term, the term where the x has an exponent of n, and then the one next to it is going to have an exponent of n minus 1 all the way down until you have x to the first and then a constant at the end. What we're going to be looking at to find the horizontal asymptotes is the leading coefficients. Okay, so n is the degree of the numerator, and m is the degree of the denominator. I have that written here. So if n is less than m, then the horizontal asymptote is going to be at y equals 0. The horizontal asymptotes will always be y equals, because that's the equation for a horizontal line. So if the degree in the numerator is less than the degree in the denominator, it's going to be at y equals 0. If the degree in the numerator is greater than the degree in the denominator, then there will be no horizontal asymptote. And if the degrees are the same and they're equal to each other, then the horizontal asymptote will be y equals the coefficients of the numerator, of the leading coefficient from the numerator and denominator, a sub n over b sub m. So those leading coefficients will be the horizontal asymptote. So I have some here. My degree of the numerator is a 1. Denominator is 2. So that means the n is less than m, which means I'm going to have a horizontal asymptote at y equals 0. Understand that this is the x-axis. So in the next one, I'm going to label these A, B, and C. So in the next one, I have my degrees are both quadratics. So when they're equal to each other, I use my coefficients. So it's going to be y equals 8 over 4, which reduces to y equals 2. And then in the last one I have a cubic over a quadratic, which means my n is greater than my m, which means that there is no horizontal asymptote. Go ahead and try this one. Joke time. Why are elephants banned from public swimming pools? 'Cause they always drop their trunks.